Hello there, this is Nile from Toolchefs and welcome to this new video for the Stadium series. So what we're going to do now is we're going to have a look at a problem that you face sooner or later whenever you have to populate stadiums. And that is basically when you have, sitting clips and that were recorded on an actor that was sitting on a chair, but that chair had a different height than the seats of the Stadium 3D model. So for instance, this is what, let's pretend this cube here is our seat, and we see here our character is floating because this clip wasn't really made for this kind of height. So the chair that was used by the actor was actually different than the height of this cube. So in this case, the character is floating, but you could also have the other case where the seats are actually higher and the back of the character is actually intersecting the seats. So what you would do usually if you wanted really to fix this problem, you would create maybe a new clip and then use that one. So that clip would be specific for the height of these seats. Otherwise, sometimes you don't really care about fixing this kind of stuff, or maybe your crowds are very packed, so you don't see this kind of gaps between the back of the character and the seats. Sometimes they're night shots, so you don't see the shadows, or maybe you're just happy with this result and you don't really care about having a specific clip for these seats. And so that's totally up to you. But anyway, if you really wanted to fix this for all the characters, you would need to find a solution for that. So with Atoms, we have created some tools that will help you fix this kind of situation. So the first thing that we're going to do is we're going to create an eye field with the height field manager. So I selected both the cube and the plane, so that those are gonna they're gonna make my eye field. Let me first move away the cube because I want to show you something first. So let me reload that. I'm going to go on the agent group, and on the state machine I'm going to apply the eye field. Wait just a second. And now the agent is actually the terrain adaptation is happening on this eye field. So in this case, of course, the plane is flat, so the agent is just being adapted to this plane. So for the pelvis and the feet, what Atom is doing is it's finding an intersection with the ground and then adding the pelvis height and the feet height that are stored within the clip. And that's basically what we see. That's why we just see the character being shifted a little, because based on this intersection and the values that we have in the Atoms clip, then this is the result that Atoms is evaluating basically. So, but if I move this cube back there and I reload this and I click rewind, now the intersection for the pelvis will be on this cube here, so it will be around here. And then by adding the pelvis height, this is what we see. So the character is floating even more than before. And so of course, this is not acceptable. Like it would, the situation, the result that we had before was actually better than this one. But with Atoms, we have created some tools that will let you actually adapt the character on the actual seat height. So first thing that we're going to do is we're going to go on the state machine and click on seat adaptation. And we have the same option on the clip reader module. Nothing is happening because we need to do something also on the Atoms UI. So if you remember, so this is the setup that we have created earlier for when we were configuring our agent type and animation clips. I'm gonna select the seat because this is actually the clip that we're playing. And if you go down here, we'll find the enable seating option. So I'm gonna enable that. And then if I expand the seating factor, we see this graph here. I'm gonna select all the keyframes. I'm gonna move them up, and then I'm gonna click register. So by doing that, I'm telling Atoms that this clip is sitting throughout the entire frame range, because both keyframes, that basically the first keyframe is at the frame 0 and the last keyframe is at the last frame of the clip. This is telling Atoms that the clip is sitting throughout the entire frame range. So if I press rewind now, we see that the agent is actually sitting in a different way, but it's not really the correct result. What's happening here is if we show the skeleton, and if we hide the cube just for a second, we see that the pelvis is there. So this is the joint that is being adapted to the ground. And if we unhide now the cube, we see that actually the pelvis is exactly on the on that cube. But what we need here is we need to add some sort of offset. So let me go back to skin mode, and that offset can be provided here in the agent type. So down here we'll find the seat height offset. So if you start adding values here, like maybe it could be 10. So let's rewind and see. Now it's a bit higher, but we need to have some, like a higher value. Maybe 13 is gonna be okay. Now click rewind. Yeah, 13 is better. So now the pose of the character is overall better, but we still have some problems here. So we have the hands that are, intersecting the legs. Before we fix that, I want to show you how you can animate this stuff. So for instance, if I animate the state, and if I go to state 0, which is the standing state, we'll see some weirdness going on. As you can see here, we had some pops that of course are not acceptable, so we can fix those. And to do that, if you remember correctly, in the state machine we had a sit and a stand state, but also we have this transition, and on the transition we added a transition clip. So for the stand, we really don't need to do anything, because we don't need to tell Atoms this clip is sitting down, because of course it's not sitting, it's just standing. But for the sit to stand, we need to provide some sort of values. So for instance, we can enable sitting here, and then on the first frame, we'll know that the clip is sitting, right? So because it's sitting here, then we can go maybe at frame maybe 23, still sitting, and say we're still sitting here. And then we can go at frame maybe 60. Yeah, 60 should be okay. And we can say the clip here is not sitting anymore, and then the last frame is at 0. So we're telling Atoms at that frame, like from frame 60 and forward, that the character is actually standing. So these frames here are needed by Atoms, because here is basically blending between the standard height field adaptation and the sit adaptation. So now if I press Ctrl S, so I register the clip, and I now rewind and press play, we see that the transition is going to be much better. So that's great, and you need to do the same, of course, for all the sitting clips that you have in your in the Atoms UI for your characters. If you are planning to use this feature, so if you have a stand to sit, you will have to do this kind of blending as well there. And if you have any other sit clip, you would have to set the sitting factor to 1 for all those clips as well. So let me remove this animation for now. And if I press play, we see that basically we have the character that is just, playing the sitting clip again. Okay, now we are going to have a look at two methods to fix the arms. With the first method, we're going to export a new FBX, and then we're going to apply that on our agent as a clip. With the second method instead, we're going to just use the joint transfer module in combination with join metadatas. So to fix the arms, what we have to do is we can go under tools and then joint transform tool. We can select this joint and rotate it. So we can do this, that, and then we can also select this joint here, and we can rotate that one too, like this. And maybe we can do this. Okay, it's a bit too high, so let's just move it down a little. Like that is fine. So in this way, if I press play, now the animation is much better, and it looks better. But of course, if you have several agents, you might want to, to apply the same offsets on those agents, and you could do that by just, moving out these values from the overrides to the actual values of the module. So we would have to move the joint name, but also the rotation offset. From the overrides again to the sorry, let me close that one, from the override to the rotate value here. This of course would be kind of tedious if you have a lot of agents, and if they're not all playing the same clip, you would have in that case you would apply the same override to the same values to all those agents. So maybe again in this case it would be just better to edit the clips that you want to use for this specific case, and then export them so that you can reuse them with Atoms. So what we're going to do now is we're going to set the start frame to 0 in this case, and this is because I'm going to export this animation by using the same range of the sit clip, which is 0 to 153, I think. Yeah, and then we're going to reuse that clip within this shot. So I'm going to export, FBX exporter, select an agent group. So this tool actually lets you export an FBX for all the agents that you select in this list here to disk. And of course, we just have one agent, so we just see one here, and that's basically what I selected. Then we can provide the start and end frame. So we're going to say 1 and 154 because we're starting at frame 1 with the sim. So to have all 153 frames, we need to add like 1 to the last frame here. Then I'm going to select an output path for the clip. So like this. And I can just click run. So now the clip has been exported. If I go here and I duplicate the sitting clip like this, and now I can select the FBX that I just exported. This. I'm gonna click register, and now I have that new cycle here. If I press play, this is the new stand, the new seat. You have, as you can see here already, there are a few things that we need to change. For instance, here the direction is saying that is facing the z-axis, but it's actually facing the x-axis now because this character here has been rotated by Atoms to face the x-axis because that was an input on the grid layout. So Atoms did what we told him to do. So we're just gonna change that. We're gonna register. You see here there is some weirdness. Also the offset is not totally correct, and this is because if we go down here, let me also disable the sitting because we don't care about that for now. We see here we are still having the same offset that we had with the other clip, but the other clip was facing the z-axis. So we need to probably move this one on the x. Click register. Now it's better. And also what you notice as soon as we play this animation, so let me delete this stuff. I'm going to add a clip reader. I'm going to say I want the sit clip, and that's basically where it is. But if we do sit 1, we see that the agent is actually floating again, and this is because here the pelvis is in a different position than the pelvis on this clip. So we need to offset the clip a little bit more. So we need, I think, to bring it down a little bit more. So let's say if we try 50, register, we need more. So let's try with maybe 55. A bit too much. So maybe let's do 53. No, not 35. Sorry about that. 53. Okay. Like this. And this is now okay. So we could have like one agent playing, so all the agents playing the sitting clip, playing this clip instead of the other one. But again, you would have to also to modify all the other clips that are, playing, like working together with the sit clip. So maybe the sit to stand. Also, if you have any other sitting idle clips, and so on. If you use this approach, you then basically don't need to provide any height field, which actually is going to speed up your the performance of your scene. So as you can see, actually here we don't provide any height field. We have the grid layout enabled for layouting our characters with the apply height field, apply pelvis height offset. And basically, so you will find all your characters being placed in the stadium without the need of using any height field. Okay, now let's have a look at the method which involves using the join transform and the join metadatas. This method is more flexible to what we have seen earlier, simply because you'll be able to work directly within the simulation, and it will work on any agent that you have in the simulation. So for instance, here I have 2 agents that I've already created. I'm going to create a new join transform. Then I'm going to open the AtomsUI just a second because I care to see the joints that I want to edit. So I've activated the draw joint names here. So I need to change the right arm and the left arm. So let's say, for instance, right arm, and I want to rotate maybe 20, minus 20 maybe. Okay, something like this. Maybe this one, yeah. So maybe minus 10. Okay, great. So minus 10 is fine for that arm. So then maybe you can create a new joint transform, and this one is gonna be left arm. And so here we said -10, so let's try with -10 here. Okay, it's pretty good. Maybe we can give maybe some more. Okay, yeah, looks good. Maybe a bit more, let's say -10 even here. Yeah, okay, anyway, it's better than before anyway. So okay, so basically this is the ideal position that we would like to achieve whenever the agents are set down. So we're gonna basically activate dynamically these joint transform modules while we're playing the simulation. So what we're gonna do, we're gonna call this one right arm. So GT, something like this, and then left arm GT, something like this. So then basically they're easier to figure, I mean, it's gonna be easier to figure out which one is what. I'm gonna set the weight to both to 0. Maybe it won't make sense straight away, but you will in a second. So 0, sorry, this one I missed it. So 0 and then 0, okay. Okay, so now let's have a look at adding those joint metadata. So what we need to do is we're gonna need to go in the clips that we want to edit. So the ones that have the, you know, the ones that are sit clip. So for instance, this one, and then we're gonna need to add a metadata. So for this one, we need to, of course, attach the metadata to a joint, and then we're gonna access that metadata on that joint. So here I don't particularly care about which joint, so I'm just gonna select maybe the hips, simply because I can basically use the same metadata for both arms. And then here basically you provide the name of the joint. Then here I'm gonna call it maybe JT_drive, and this is gonna be a double. I'm gonna add it. So the value range is gonna be between 0 and 1. So I'm gonna edit that. Here you have the name, the full name of the. So this is basically the name of the metadata, the name of the joint, and then here is the type. Okay. So basically what we do here is we want to select all the keyframes and then move them to 1. Are they on 1? Yes. Then I'm gonna save this one. So basically then we want to use this JT drive metadata to drive the joint transforms here. So I'm gonna move the AtomsMaya over here. Then I'm gonna create a copy metadata. I'm gonna move this one up here. Then the source then is gonna be JT drive. And then it's gonna be at that was hips, yeah. And then what we want to do is we want to set the weight of these two modules. So first one is gonna be right arm. So right arm weight. So maybe you're not aware of it, but basically from Atoms Crowd 4.0 you can drive the attributes of each module by basically setting metadatas that follow the naming convention, this naming convention. So it's going to be module name at attribute name. By default, when you use the at, this basically is used for joint metadatas like we did here. So here instead we first specify the metadata name, and then it's going to be at the joint name. So if you have this flag on, which is sent joint metadata, these will basically will try to apply these on a joint, but it's not what we want to do. We want to actually set it on the actual agent. So then we can drive the right arm JT, the weight of the right arm JT module. And then what I'm gonna do is I also want to set this at the end frame. And as you can see, as soon as I activated that, we see here we have the arms popping in the right position. So then here what we're gonna do is, so we're gonna create a new copy metadata. So it's gonna be copy, then paste. I'm gonna move it up. And then here instead what I want to have is going to be left arm. And as you can see, as soon as I edit that, here we have the left arm over here as well. So what we want to do now is also we want to make sure that this attribute is also set for the, this metadata is also working on the other clip that we use for, for the transition, so the sit to stand. So I'm going to again set it on the hips. And then it's gonna be again the same name, so JT drive, so sit to stand, hips, JT drive, double, okay. And then here what we have to do instead, we have to animate it a little. So for instance, here it's gonna be starting at 1, and then it's gonna be probably somewhere like here. So it's gonna be at 1 all the way maybe to 25. And then it's gonna go down to maybe 56 is gonna be at 0. Okay, so I'm gonna save this one, and then if we go back here in the sim, and on the state machine we animate the state, so we go basically from 1 to 0, so we're gonna go here, and then we set another keyframe like this. I'm gonna press play. So you see here while we well, we're actually, standing up, basically we're in the transition, because of course the joint transform offset that we're applying is not good anymore for those kind of poses. Here, basically the arms are actually intersecting with the knees. So in this case, basically we have to tweak the simulation even a bit more. Of course, if you're just happy to have the hands, intersecting with the legs, during the sim, you can leave the simulation like this, but maybe it's not good enough for you. So what we can do here maybe is to create a new joint transform. So it's going to be joint transform. And what we want to do here is, again, we want to apply this one on the right arm. And what we want to do is we want to rotate the arm this way, so outside of the leg, so they don't basically intersect anymore. So let's try a right value for that. So now it's going to be maybe -20 or something like that. Maybe a bit more, -30, something like this. Okay. And then we're going to do also, so this one is going to be maybe right arm JT2. And then I'm going to maybe copy and then paste. But I want this one on the left arm. Okay, so maybe -30 there is a bit too much, maybe -20. No, sorry, not 2. 20 is enough. Actually, this one maybe even a bit more. Actually, let me try something here. Maybe the right axis is this one. No, let's stick with the rotation here. Okay, something like this. Maybe we can even say -40. Okay, so again, what we want to do here, we want to set the weight to 0 and the weight to 0 here. And then what we're gonna do is, what we need to do is basically we need to create a new metadata here for driving these two new modules. So to do that, basically what we have to do is we go basically at the beginning of the simulation here, maybe say we call it site, add, go down here. So the beginning of the sim, we don't want those joint transform to be activated, so the value is going to be 0. Here again, maybe it's fine what we have, so maybe let's go at frame 11. So we say 0 there. Actually, let's use something like this. Then we go maybe at this frame and maybe 30. We're gonna say we want this finally to be activated, so we go there, and then we go at frame maybe 56. 56 we set another keyframe over here, and then we go at frame there. Okay, 76. Okay, so it's not active anymore. Probably we're gonna have to come back here and tweak these values a little, but let's stick with this for now. So again, this is called JT drive site. So if we go here and we copy the modules again, paste, go up. Sorry, no. So this is, let me copy paste it from here. So copy the hips, yeah. Okay, it's gonna be okay. All right, I'm J2, and then I'm gonna copy paste this again. I'm gonna move this one up, and then it's gonna be left arm. Okay, so if we go now and press play, So the first joint transform is working fine, you see there, but this one is not really. This one is still needs some improvement. So that one is the left. Oh, sorry, this one I should have called it something different. Left arm, something like this. And this one, so if we go back on the first frame and we set the weight again to 120, it's not enough, maybe 30, something like this. Okay, let's set the weight again to 0. Yeah, much better now. So anyway, it's not like a great motion probably, but at least you don't have the intersections and the simulation is looking much better compared to what we started with. Okay, and this is all for this video. Thanks for watching.